Okay, today we're going to talk about relations and functions, and then we're also going to talk about domain and range. So we start here on 5.1, okay, lesson 5.1. I'm not sure what the page is, but I'm sure you can find it. It's got this big vending machine on the front here. So when we talk about relations and we talk about functions, it's really all about input and output. Hey, what do you input and what are you going to get for your output? What are you going to put in for X and then what are you going to get out for your Y? So they relate the functions and inputs and outputs, they relate it to a vending machine in that, vending machines have like B3. When you select B3, you may get the Skittles. But if you do B4, you may get Starburst. The point is that when you have an input, whatever button you input, there should only be one output. You would never push B3 and the Skittles and the Starburst would come out. I mean, though that'd be a great day, that doesn't happen. Okay, when you put in one code, you get one thing back. So here you have a vending machine. This is a DVD vending machine. And you see the different DVDs and the codes for the buttons to push to get certain DVDs. So number 1 asks you, what DVD would you receive if you inserted your money and pressed A1? So if I pressed A1, right here I would go A1 and I would get the Hunger Sports. And I don't like using black on here. I'll change colors. Now, for B, what if I press C2? Okay, C2 is right here. So you go C2, the Light Night. Okay, so you put the Light Night. And then we'll scroll down a little bit here. And then it says B3. Okay, B3, here's B3, so B3, and you get the Amazing Insect Man. Great titles. Okay, pretty simple. You push a button, you get an input, you get an output. I inputted A1, I got Hunger Games. I inputted C2, I got the Light Night. You would never input C2 and get the Hunger Sports and the Light Night. That just wouldn't make sense. So, move on to number 2. Now, it says, assuming the machine were filled properly, describe what would happen if you press the same button twice. Think about the candy vending machine. Hey, if I pressed C2 twice, if I put my money in, push C2, then I put my money in again and push C2 again, what am I going to get? Okay. If you said that you're going to get the exact same thing, then you are correct. You should. If you input the same thing, you should get the same output. Okay. Okay. Hopefully that makes sense. If not, please pause the video here and raise your hand and I'll come by and help you out. Okay. Let's move on to the next page. Alright, here we are with number 3. So number 3 says, each time you press the button and input, okay, every time you press a button, you are giving an input into the machine, okay, and then the machine, okay, gives you a DVD, and that DVD is called an output. So in a candy vending machine, you would input a code, and then whatever candy you got would be the output. A soda vending machine would be the same thing. Okay. in the DVD vending machine situation, does every input have an output? If you look back at the DVD, and let's, you can scroll, you can look back at the page, but if you look at the DVD machine, you'll notice that one of the DVDs is actually sold out. So if you chose, I think it's B1, if you chose B1, there would not be any output. Nothing would come out because the machine sold out. So sometimes when you put an input, there is no output. So the answer is, in the DVD vending machine situation, does every input have an output? And the answer is no. B1, I'm pretty sure it's B1, does not. And you can put sold out if you want to. That's an O. Sold out. So, okay, number 4. Each combination of input and output can be expressed as a mapping written input, output. For example, if you push B2, you get the Amazing Insect Man. And the mapping has your input and then an arrow drawn to your output. So, I'm not going to go through and write all the combinations, but basically, you're going to start with A1, and you're going to put what you would get for A1. Okay, and then you're going to put A2, draw an arrow, and then draw an arrow. And then you're going to put A3, draw an arrow. And then you're going to put B1, B2, B3, and draw an arrow to whatever it is you get. So I'm not going to write all the titles in there. I think you could do that. But it's asking you to write all the different combinations you could, that could be pushed to get different DVDs. So you're just going to write them all out. And then there's C1, C2, and C3 also. So the next one says to create a table to illustrate how the inputs and outputs of a vending machine are related. So if we look at a table, we're going to make an input-output table. An input-output table looks, make it like this. Okay, where this is your input, I'll put I for input and O for output. When I input A1, what do you get? Okay, and you write down whatever you get. When you push A2, what do you get? When you push A3, what do you get? And so on and so forth, and then B1, B2, B3. Hopefully you have enough room here that you can do all of them. I kind of made mine C2, C3. I kind of made mine a little too big, my word's too big. But this is an input-output table, and it may look familiar whenever we do tables. You remember tables from before, you had something like this. You had X and Y. And when I put in 1, I got 3. And when I put in 2, I got 5. And 3, I got 7. It's the exact same thing. Okay, input and output. X is always the input. Y is always the output. Here we're just dealing with DVDs, but it's the same thing. Input and output. It says mappings that relate values from one set of numbers to another set of numbers can be written as ordered pairs as well. A relation is a set of ordered pairs. So ordered pairs is like a coordinate. So if we look at up here at our table, okay, this would be an ordered pair. 1, 3, and 2, 5, and 3, 7. So, we would write, I'm going to just write combinations down here, but 1, 3 in parentheses, that's called an ordered pair. Okay, and then we can write the other one, and that's 2, 5, and 3, 7. Those are called ordered pairs. Okay, ordered pairs. Each one of these, that's an ordered pair, that's an ordered pair, this is an ordered pair. A relation is a set of ordered pairs. So this is in a relation. You have a set of ordered pairs. Okay. Let's go on to the next page. So here you have relations and functions. Here it says relations can have a variety of representations. There's multiple ways to have a relation. So if we look at and we consider these ordered pairs here, 1, 4, 2, 3, and 6, 5, you can write it multiple different ways. We can write it in a table. So you have 1, 4, 2, 3, and 6, 5. 1 being the x, 4 being the y, 2, 3, 6, 5. We can also write it mapping like you did with the DVDs. And then 1 draws an arrow to 4, 2 goes to 3, and 6 goes with 5. And finally, we can actually just graph all of the ordered pairs as dots on a graph. So here's a graph. My first coordinate is 1, 4. Okay, I have 1 and 4. There's my first dot. And then 2, 3. I can go 2 and then 3. And then 6, 5 is 6 and 5. So you can actually graph it as well. Okay. And now let's look at number 5. Scroll down here. Okay. So number 5 says write the following numerical mappings as ordered pairs. So I've already done, and let me actually zoom in here, make it a little, so I can write it a little bit better. Sorry guys, my allergies are bugging me. So the input was 1 and the output was -2. So if you imagine that you have parentheses here and a comma in the middle, that's really all the ordered pair is. Input, comma, output. So when we look at the next ordered pair, you have input, comma, output. Okay, input, comma, output. And input, comma, output. And I really can't draw fours. Input, comma, output. So there's your input and output as written as an ordered pair. Okay. We're going to skip around here because we're going to do some of these in class and the next time we meet. So we're going to skip over to 11, which I believe is on the next page. Yes. Actually, it's a couple pages. There you go. There's 11. Okay. Number 11 says, determine whether each list of ordered pairs represents a function. Okay, remember when we go back to the DVD example, okay, for every input, you only should get one output. Okay, imagine pushing the code for Skittles and getting a Snickers and a Skittles. That doesn't happen. Though, that'd be the greatest thing ever. That doesn't happen. Okay, in functions it works the same way. For every input, you would never have one input giving you two different answers. So when you're looking at an ordered pair, remember the first number is your input. Okay, the first number is your input, the second number is your output. If you notice that the same input is giving you two separate outputs, okay, then you have, you don't have a function. If we look at this first one, you'll notice that the input of 5 gives me 4. The input of 6 gives me 3, and the input of 7 gives me 2. Nowhere in here do I have the same input, 5, 6, or 7, giving me two different outputs. So in this case, this is yes function. Okay, there is no repeating. Now, if we look at B, you'll notice how if I input 4, I get 5. But if I look at the second set, 4 is also giving me 3. So here's a case where 4 is giving me 5 and 3. It's giving me two separate outputs. So in this case, not a function. Okay, because, and it says to explain your answers, I don't have room to fit it here, but because 4, the input 4 is giving you two different outputs, 5 and 3. Okay, go Go ahead and try the last one on your own. So, what did you get? Function or not a function? If you look at the inputs, first of all, none of them are repeating, so that should give you a first sign there. Okay, now it doesn't matter that all of the outputs are the same. If you notice that all the outputs are the same, it doesn't matter. Okay, if you think about a vending machine, okay, sometimes in a vending machine, like a soda vending machine, there may be multiple buttons that give you the same thing. So there may be like 3 rows of Gatorades. Okay, and if I push A1, I get a Gatorade, but if I push A2, I also get a Gatorade. And an A3 may also give me a Gatorade. So I have 3 different buttons giving me the same Gatorade. Okay, that's okay, because for each button, I only got one thing. Hey, if you pushed one button and got two Gatorades from 2 different rows, that would be a problem. Okay, so you only look at the inputs and see if there's any repeating. If you look at the inputs, there are no repeating ones. That means that each input is giving you a separate output. So this, yes, function. Okay. All right, and the next one we're going to do is 13. All right. So it says number 13. We're going to actually do 13 and 14. So 13, does the mapping shown represent a function? Look at your inputs. Okay. Does every input only have one output? If you said yes, then you're correct. This is a function. The 2 only gives me a 6, and that is it. The 3 only gives me a 7. The 4 only gives me a 7. And the 5 only gives me a 9. All of my inputs only have one answer. Okay, here's what it would look like if it were not a function. If the 2 gave me a 6 and a 9, that is not a function because the 2 is giving me 6 and 9. Okay, always look at your inputs. That's where your focus is. Okay, but again, this is a function. Okay, looking at 14. Does the graph shown represent a function? Where are your inputs on this graph? It might be hard to understand here, but which side is the x values? Well, hopefully you answered this side down here at the bottom. This is your x values, and this is your y values. So the bottom here, these are your inputs. These are your outputs. So when I go to my inputs, where the dots are, my first input is 0. My output is 1. If I go to 2, I have an input of 2, output of 3, and 5. I go to 4, my input is 4, my output is 4. 5 is 2, and 6 is 6. So, are there any inputs that are giving you 2 different outputs? If you said yes, then you are correct. 2, right here. We move up 2, my input of 2 is giving me 3 and 5. Okay, the input of 2 is giving me 2 separate outputs, and that is not okay. So this is not a function. Okay, that is it for 5-1. So we're going to move now to 5-2. Okay, so here we are in 5-2. 5-2 deals with domain and range, and you see math terms here, domain and range. I don't know how familiar you are with domain and range, but it's a pretty easy concept. Okay. Remember, inputs are x values, outputs are y values. So we're going to read right here. It says, the set of all inputs for a function is known as the domain. So all of your inputs, or all of your x's, is the domain. The set of all the outputs in a function is known as range. So all of your outputs, or all of your y's, are considered the range. So we're going to look at we're going to start on number 2. Okay, and it says, for each function below, identify the domain and the range. So I'm going to zoom in here to each one, and then we'll move around. Okay, so if we look at this letter A here, remember, all inputs are domain, all outputs are range. So when it asks you for the domain, you literally write, and they write these in these like funny brackets, but domain is going to be 7, 3, 5. Range is all the outputs, so 6, -2, and 1. That's it. That is domain and range. It's that simple. Okay, so when we look at B, okay, domain again is all of your inputs. So 2, 6, and 8. That's it. Range. 4. Actually, with range, you do need to put all of your outputs. So even though there's only 4 and -3, 4 is an output for 2 different numbers. So you need to put 4, 4, -3. Okay. And then C, as we look at the graph, domain is all the x values. So look at all the dots. What are the x values of each dot? Okay, this first dot right here, what's the x value? If we go down, it's 2. So the first one is 2. Okay, second dot, here's the second dot. If we go down, okay, that is 3. And the last dot right here, go down, that is 5. And range, look at the first dot. Here's our first dot right here. The y value is this way. So the y value of the first dot is 4. And then the second one is 1. And the third one is 3. There you go. Go ahead and try D on your own. Okay, I'm going to write down the domain here and see if you're correct. Were you correct? If so, great. And that's domain range. Okay, so now we're going to look at a few more examples by going and doing numbers 5 through 8 on the Okay, 5 starts with this little machine looking thing here. Okay, this is called a function machine. And there you go. Sometimes machine diagrams are used to represent functions. In the function machine below, the inputs are labeled x and the outputs are labeled y. The function is represented by 2x plus 5. So the x was your input, it goes into the machine. You put in x for the x in the function here, okay, and then out will come a y. So A says, what is the input if x is equal to 7? So if we take 7 and we input it into the machine and put 7 in for x, what are we going to get? Okay, let me change different colors here. Let's do that. Okay, so when we input 7, we're gonna input 7 first. So you have 2 times 7 plus 5. Well, 2 times 7 is 14. 14 plus 5 is 19. Now we're going to input the second one, which is negative 2. So I have 2 times negative 2 plus 5. Well, 2 times negative 2 is negative 4. And if we add 5, you get 1. 1/2. So I have 2 times 1/2 plus 5. You can do that in your calculator, or remember when you multiply to fractions, you multiply times the top, then divide by the bottom. So if I do 2 times 1, that's 2. Divided by 2, that's 1. And 1 plus 5 is 6. Okay. So my inputs, here are my inputs, and then these are my 3 outputs. Okay. So now we're going to look at letter B. B says express regularity in repeated reasoning. Is there any limit to the number of input values that can be used with this expression? So, is there a limit? Could we input anything? Or are there things that we could not input? Think about it. Okay. If you think about it, hey, I could put in anything for x, and I'm going to get any output. I'm going to get a random output. But there is no limit on what I could put into this function. Hey, any number could be used. And that's what you should explain here. Okay, I'm going to move on. Now we got a quadratic here as we look at number 6. So we have a function x and then output y, and so we're going to input these things in here. First one is going to be, my input is going to be negative 5. So every time I see an x, I'm going to put a negative 5. So I have negative 5 squared, that's squared, plus 2 times negative 5 plus 3. And we just do these separately. Negative 5 squared is 25. Negative 2 times negative 5 is positive 10. And then plus 3. So if we add all those up, we should get 38. Now, let's look at the fraction 3/5. This one should be a tough one. Okay. So I have parentheses 3/5 squared plus 2 times 3/5 plus 3. Well, we haven't really talked about this, but when you have a fraction squared, you basically just square both sides of the fraction. So I do 3 squared, which is 9, and 5 squared, which is 25, plus, then you have 2 times 3/5. Remember, multiply times top, divide by the bottom. So 2 times 3 is 6, and divide by the bottom, which is 5. Well, that doesn't go into it, so we leave it as 6/5, and then plus 3. Well, we got a bunch of fractions here, and I'm going to go back to middle school here, or maybe elementary school, and say that in order to add all these, they need to have a common denominator. What's the common denominator? Well, looks like it's 25. This is 3/1. So what do I need to multiply by? Well, the first one is already done, because it already has a 25 as a denominator. But the second one, I need to multiply both sides by 5. So I have 9/25, and I multiply the top times 5, I get 30. I multiply the bottom times 5, and I get 25. This one I need to multiply, since my denominator is 1, I need to multiply by 25. So multiply the top times 25, and that's 75 over 25. Now that they all have a common denominator, I can add them. If you add up all the numerators, it looks like you're going to get 114 over 25. That was the hard one. I'm going to give you the easy one and have you do C on your own. Okay. Well, if you input this in correctly, you should have gotten 100 minus 20 plus 3, which is 83. If you didn't get that, or if you don't get any part of this, please pause the video now and raise your hand. Or if you're doing this at home, you can send me a message on Canvas, or just come by on Monday. You can get an AL pass. We can go over some of this stuff during Academic Lab on Monday. All right, let's move on. We only got a couple more problems, so let's go to the next page. Okay. And there you go. So we're just going to do 7 and 8, and then we'll be done. 7 says, make a function machine for the expression 10 minus 5x. Okay, so I don't know, I think this is what you already have here, but if you don't, this is a function machine here using 10 minus 5x. And I'm going to have you go ahead and plug in. I'll have you do the first two. How about that? On your own. Go ahead and do it now. Okay. For your first one, 4x equals 3. You should have gotten 10 minus 15, which would have been negative 5. For your second one, you should have gotten 10 plus 30, which is 40. Now for a little more complicated one, 0.25, you should have gotten, if you put 0.25 in for x, you have negative 5. So this is what it looks like. I'll do it down here. 10 minus 5 times 0.25. If you do negative 5 times 0.25, you'll get 10 minus 1.25, and that equals, it should be 8.75. Okay, and that's the third one. The fourth one, being 3/4, you're going to have 10 minus 5 times 3 over 4. Remember, when multiplying times fractions, you multiply times top and divide by the bottom. So I have 10 minus, if I do 5 times 3, that's 15 over 4. Okay, this doesn't have a common denominator, so I need to put this over 1. The common denominator is going to be 4, so I need to multiply both sides by 4 here. So I'm going to get 40 over 4 minus 15 over 4. Well, 40 minus 15 is 25 over 4. Okay. Just some simple fractions and common denominators there. I probably did it a little faster than you might have been able to do it, but it's something that's not too complicated. You can do on your own. Alright, last problem. Creating a function machine can be time-consuming and awkward. The function, represented by the diagram in number 5, can also be written algebraically. So if we looked at the one that was in number 5, as the equation y equals 2x plus 5. For each function, it says find the order pairs for negative 2. So you're going to plug in negative 2, you're going to plug in 5, you're going to plug in 2/3, and you're going to plug in 0.75. There's A, B, C. No, just A and B. Sorry. So you're gonna plug in these four inputs into each one of these outputs and tell me what you get. Okay, go ahead and do that on your own. I'll return with the correct answers. Okay, here are your answers. Hopefully you got all those right. If not, I know the fractions and decimal ones are fairly complicated. You're probably not going to see anything in crazy fractions or decimals like that on a homework or test. But that's just to test kind of your math skills there. If you didn't get all of them, don't worry. We'll talk a lot about this over the course of this next unit. So that is your Springboard lesson for homework. Okay, and if you have any questions, just mark them down, or we can go over it in class the following time we meet. Thank you guys. We'll see you next time.